12th Science Chemistry. Transition and inner transition elements.
Hello students, today we are going to discussing on the compound that is potassium dichromate. In previous lecture we have studied detailed about the compounds of transition element. Out of that we have studied detail about KMnO4, that is potassium permanganate, preparation of KMnO4, chemical properties of KMnO4, oxidation property of KMnO4, uses of KMnO4, that all have been studied in previous lecture. Then today we are going to discussing with you about the detailed study of the potassium dichromate. Then see here, potassium dichromate, the molecular formula potassium dichromate is K2Cr2O7, in which chromium possesses, here chromium possesses +6 oxidation state. That means in higher oxidation state, transition element forms the coordinated compound and or complex compound. That is potassium dichromate is a complex compound of chromium in its +6 oxidation state, and in which Cr2O7 2- that is dichromate ion is present in it. Then we will discussing first of all of preparation method of potassium dichromate. Then see here the ore from which potassium dichromate have to be prepared, that is chromite ore. Here from chromite ore, which having formula FeO.Cr2O3 is the chemical formula of chromite ore, from which we have to prepare the potassium dichromate. First of all, we have to discuss about the nature state of that potassium dichromate. Orange red color crystals are of potassium dichromate. And see here, the potassium dichromate is prepared in laboratory as well as in industry. That means when it is prepared in commercially, then there is an industrial method is used for the production of K2Cr2O7 from its chromite ore. Then here we are going to discussing about the industrial preparation method of K2Cr2O7, that is potassium dichromate. Then first of all, see here there are many steps, that is of the preparation of potassium dichromate. See here, in first stage the chromite ore, that is FeOCr2O3, that chromite ore, first of all it is which is taken from the earth crust, it is washed with stream of water to remove the gangue, and it get pulverized or it is crushed into powder form, and that pulverized chromite ore which is taken here and it is fused with, or oxidation of that chromite ore takes place in reverberatory furnace using excess air, and in which anhydrous sodium carbonate is used here, that is washing soda. Anhydrous washing soda or potassium carbonate is used during the preparation of K2Cr2O7, and air is passed for, that is excess air is passed for oxidation of that chromite ore. Here this fused mass which is heated strongly in reverberatory furnace, and here chromite ore get converted it into sodium chromate, and with the formation of sodium chromate, that is Na2Cr O4, Fe2O3, that is oxide of iron formation takes place with the liberation of CO2 gas. See here, in this process, in reverberatory furnace, this process takes place. During this process, the flux is used. Flux, that is calcium carbonate. Calcium carbonate is used, that is known as limestone. Limestone is act as a flux during this process, which is used to make that substance, make that mixture porous, to carry out the more and more or complete oxidation of ore and to get the sodium chromate. First of all, see here, we have to balance this reaction. Therefore, 4 molecules of that ore which is heated with washing soda, that is sodium carbonate, and it is passed through the excess air to get converted it into sodium chromate. 8 molecules of sodium chromate with formation of Fe2O3, that is iron oxide formation takes place with liberation of CO2. CO2 gas is a waste gas which is removed away from the exhaust, and the remaining material in which sodium chromate is there, which is extracted with water, and the sodium chromate which is extracted with water, it is again treated with concentrated H2SO4 in second stage. Therefore, in second step, sodium chromate, that is Na2CrO4, is treated with concentrated H2SO4, which is converted it into, that is sodium dichromate. That means sodium chromate is converted it into sodium dichromate, that is Na2Cr2O7, with the formation of sodium sulfate, that is Na2SO4H2. That means it is a hydrated form of sodium sulfate is obtained here. Then the reaction we have to balance here, that is Na2CrO4 plus concentrated H2SO4. It gives Na2Cr2O7 with liberation of Na2SO4.H2. That means here we have to write twice Na2Cr O4. Then the sodium dichromate is obtained in second step, that is heated with, or KCl is added into sodium dichromate. And here, when sodium dichromate is treated with aqueous solution of KCl, on heating it converted it into K2Cr2O7, that is orange red color PPT is formed in this last stage. Then that K2Cr2O7 having the less soluble at low temperature, therefore it get precipitated after cooling. Then here production of K2Cr2O7 takes place in third stage plus twice NaCl. That means here production of K2Cr2O7 from chromite ore takes place in 3 steps, isn't it? Then now we are going to discussing about the chemical properties of K2Cr2O7. Acidic K2Cr2O7 is a strong oxidizing agent. That means it oxidizes to the different types of compounds or ions. Then first of all we have to discussing on the oxidation process of I minus, that is iodide ion. See here K2Cr2O7, that is in acidic medium, that is potassium dichromate in acidic medium. That is acidic medium, to make it acidic H2SO4 is used here. Acidic K2Cr2O7 is a strong oxidizing agent. Therefore, it oxidizes to the iodide ion present in Ki, where Ki solution is colorless and K2Cr2O7 is a orange color, orange red colored solution is there. In acidic K2Cr2O7, that is potassium dichromate, oxidizes to the I minus ion from Ki and it converted it into the K2SO4 Cr2SO4 thrice and iodide ion which is present in Ki get oxidized into iodine molecular form. That means here -1 oxidation state is converted into 0. When iodine is in molecular form, oxidation state is 0. That means here oxidation number increases. Therefore, I minus iodide ion oxidizes to the iodine solution which is brown in color. Here K2SO4 which is colorless. Therefore, orange red color changes to brown color which indicates here I minus ion in the solution of Ki is get oxidized into iodine solution. That means here acidic K2Cr2O7 act as a oxidizing agent and it oxidizes to the I minus ion, iodide ion into iodine solution. First of all, we have to balance the reaction. Therefore, K2Cr2O7 here 7 molecules of H2SO4, 6 molecules of Ki, it converted it into 4 molecules of K2SO4 and thrice iodine molecules and Cr2SO4 thrice plus 7H2. That is the chemical reaction in balanced form. Now we are going to discussing about the one more oxidation process, that is acidic K2Cr2O7, that is K2Cr2O7 in acidic form, that is H2SO4, which act as an oxidizing agent which oxidizes to the H2S. Here oxidation of H2S, that H2S contains S2 minus ion is present, that is sulfide ion present in H2S which get oxidized into colloidal sulfur. That means here K2Cr2O7 in acidic medium, that is H2SO4, we have to balance side by side 4 H2SO4 molecules, it plus thrice H2S, it converted it into K2SO4 plus Cr2SO4 thrice plus colloidal sulfur is obtained here. Then we have to balance the same reaction. Therefore, K2SO4 Cr2SO4 thrice plus colloidal sulfur which is present here, that is thrice yes colloidal sulfur. Then have to balance here 7H2O, that is the oxidation of sulfide ion into colloidal sulfur. Here also oxidation state of sulfur -2 increases to 0 because here colloidal sulfur which is present in molecular form having the oxidation state 0. That means here oxidation state increases and sulfide ion undergoes oxidation due to the acidic K2Cr2O7. That is the chemical properties, oxidizing property of acidic K2Cr2O7. These two reactions indicates that K2Cr2O7 potassium dichromate, that is acidified K2Cr2O7, act as a strong oxidizing agent. Then we have to discussing about the uses of K2Cr2O7. First of all, K2Cr2O7 which is act as an oxidizing agent used in the laboratory. It is used in the tanning process of leather It is also used in the volumetric analysis of different compounds or different reducing agents. It is also used as a chemical reagent in industries or in chemical laboratories. It is used for preparation of dyes and drugs. That is about the potassium dichromate. Now we are going to discussing about the common properties of transition metal. Overall, there are transition metals present in 4 series. First transition series, second transition series, third transition series, and fourth transition series. All of you studied the detail about that elements present in those 4 transition series. Then, what are the common properties between those elements, that is transition elements, or it is also called as D block elements. Then we have to discuss about the common properties of D block element or transition elements. Then see here the elements, transition elements which is present in 4 series, they most of them are hard. They have high density, and they have, as they have high density and hard, they forms the covalent compounds or coordinated compound. Therefore, they have high melting point and high boiling point. They are also good conductor of electricity and heat or thermal because they have typical metallic character. As they are metal, they have high tensile strength. They have ductility as well as they have malleability. They can form the alloys with transition metals, or they can form the alloys with non-transition metals also. Their compounds and elements which are paramagnetic in nature, that means they attracted in magnetic field, and these all act as a good catalyst, that means they have catalytic property. These are the common physical properties of all D block element which is shown commonly in all transition metals. Then what are the common chemical properties shown by the D block elements, that is transition elements? First of all, they all are metal, that means they have typical metallic characteristics. That means they are electropositive in nature, that means they forms the cations. They have tendency to lose electrons and they forms the cations because of their outermost n-1d orbital is incompletely filled. Therefore, they forms the cations. Therefore, they are electropositive in nature. Similarly, this shows variable oxidation state. They shows variable oxidation state. They form the colored complexes or colored compounds. Then they are act as a good reducing agent because they have tendency to lose electrons, and therefore they act as a strong reducing agent. They forms the insoluble oxides or hydroxides. For example, insoluble oxides, that is copper forms CuO or Cu2O, cuprous oxide, and cupric oxide which is insoluble in water, as well as zinc oxide, ZnO, that is titanium oxide, TiO2. These type of oxides of transition metal, they are insoluble in water, and as well as they forms the hydroxides. For example, CuOH twice, or it also forms TiOH twice, ZnOH twice are the examples of hydroxide of this transition element which is insoluble in water. And here one more property, that is iron like cobalt, copper, molybdenum and zinc. They have biological character because these elements present in the living organism which act as a biological, having a biological importance. Therefore, because of these elements present in the living organism, they act as a biocatalyst. That means they act as a enzyme or biocatalyst, and they carried out different type of biological processes takes place within the cells of living organisms. Then that is about the common properties of transition elements of overall D block element. Then there are some differences in the D block element. All of you studied that is transition elements which is present in 4 transition series. Then the elements which is present in first transition series, we have studied detail about the first transition series elements. Then what are the difference in the properties of those elements present in different transition series. That is, see here, there are different chemical properties shown by the elements which is present in different series also. Then what are the different properties shown by the elements present in different series? That is, the elements which is present in second transition series or third transition series or fourth transition series, they forms the most stable oxides. For example, ruthenium oxide, that is Ru4, in which ruthenium possesses +8 oxidation state, and osmium oxide, that is which having +8 oxidation state. That means in third transition series, ruthenium shows highest oxidation state, that is +8, and osmium also shows +8 highest oxidation state. But in first transition series, manganese shows +7 oxidation state. That is the highest oxidation state shown by the manganese which is present in first transition series. Then one more difference in their compounds is that they show the higher oxidation state. In their higher oxidation state, they forms the compounds. Then the compound which is formed in higher oxidation state of second or third transition series element is more stable than the compound which is formed by the elements in first transition series in their higher oxidation state. That means molybdenum, which is present in second transition series, that and tungsten. Molybdenum in its +5 oxidation state, that means molybdenum 5, that is in +5 oxidation state, and tungsten in +6 oxidation state. They forms the most stable compounds than the chromium in +6 oxidation state, and similarly manganese in +7 oxidation state. That means here molybdenum in +5 oxidation state, it forms the most stable compound. Then the chromium forms the compounds in +6 oxidation state. Chromium is present in first transition series element and molybdenum present in second transition series elements. That means the compounds of first transition series element in their higher oxidation states are less stable, while the compounds are formed in higher oxidation state of molybdenum and tungsten, which is present in second and third transition series, which is most stable compounds. That are the differences between transition elements in those series. That is all about the transition elements. Thank you.